Welcome students in the series of objective type question. Practice conceptual question part 3. Now, which is from the chapter Motion in a Straight Line, class 11th physics. Let's take 21st question. If you want to see students love what is the previous one, go and check the videos and in the list PCQ2 you will be get this. A car is moving along a straight road with a uniform acceleration. It passes through points P and Q separated by a certain distance with velocities of 30 km per hour and 40 km per hour respectively. Velocity of the car exactly midway between P and Q is 33.3 km per hour, 20 km per hour, 25 root 2 km per hour, 35 km per hour. So the solution is, let S is equals to distance between P and Q. Distance of midpoint PR is equals to S by 2. We have V square minus U square is equals to 2AS. So from here we get A is equals to V square minus U square by 2S, which is equals to V square Q minus V square P by 2S. It is a complete description of that question. VQ square minus VP square is equals to 2AS by 2, which is AS. So VP square minus VQ square minus VP square by 2S into S is equals to VQ square minus VP square by 2. VR square is equals to VP square plus VQ square minus VP square by 2, which comes VP square plus VQ square by 2. This is the average velocity. So VR is equals to VP square plus VQ square by 2 with root. If we put these values, we get the result 50 by root 2, which is the option in 25 root 2 meter per second. I hope you will be understanding, students, how this will become. Hence, we are saying the correct option is option 3. Next question. A train is running at full speed when brakes are applied. In the first minute, it travels 8 km and in the next minute, it travels 3 km. Initial speed of the train is 150 meter per second, and after that speed changes. So speed 175 meter per second, then after 200 meter per second, then 225 meter per second. So the solution of this question is, like from A to B there will be 2 steps. In a 1 minute it travels 8 km, and other next minute is 3 km. So let's initial velocity of the train, that V is equals to ut plus half, S is equals to ut plus half at square. So S is equals to 8 U into 1 half into A into T square. So that is for AB for next 2 minutes. 11 into U into 2 half into A into 2 square. That comes 2U plus 2A. So after solving, we get the value of U, which is 175 meter per second. Hence, the correct option is option 2. So the next question is, a body covers 30 meter and 40 meter during 10 and 15 seconds respectively. The acceleration and initial velocity of the body are respectively 2 meter per second square, 35 meter per second, 2 meter per second square, 11 meter per second, 11 meter per second square, 2 meter per second, or 1 meter per second square, 10 meter per second. So the solution is, the body covered 10th in 30 meter and 15th in 40 minute. So 40 meter. So let's initial velocity of the body is 0, and distance traveled by the nth second is equals to Sn is equals to U plus half A by 2 to n is minus 1. If the initial velocity is u, so 30 is equals to u plus half a times 2 times 10 minus 1. It comes u plus 19 by 2a, that is 60 is equals to 2u plus 19a. Also 40 is equals to u plus a by 2. 2 into 15 minus 1. So it comes u plus a by 2 into 29. That comes 80 plus 2u plus 29a. Solving equation number 1 and 2, we get u is equals to 11 meter per second, which is the option 2. Question number 24 is a body travels 200 meter in the first 2 seconds and 220 meter in the next 4 seconds. The velocity at the end of the 7th second from the start will be 10 meter per second, 15 meter per second, 20 meter per second, and 5 meter per second. So the solution of this question is, this is the diagram. U is the initial velocity of the body. In the first 2 seconds, distance traveled by the body, 200 is equals to 2 into u plus half into a into 2 square. So 2u plus 2a. In 6 seconds, the distance traveled by the body from the start, 200 plus 220, which comes 420 meter. So 420 is equals to 4 into 6 plus half a times 6 square, which is equals to 6u plus 18a. Solving a is equals to minus 15 meter per second square, u is equals to 115 meter per second. So v is equals to u plus 18. We put all these value here, get the value of v 10 meter per second, which is the option first. Next, a particle start moving from the rest under uniform acceleration. It travels a distance x in the first 2 seconds and a distance y in the next 2 seconds. If y is equals to nx, then n is equals to 1, 2, 3 or 4. So, solution is the particle moving A to B in x in 2 seconds, B to C in 2 seconds in a y distance. So, initial velocity of the body is 0. A is the acceleration of the body given y is equals to nx and x is equals to half 2 square, that is a 2a. So is equals to x by 2. X plus y is equals to 0. So half a into 4 square, which comes 8a. When we solve, x plus 2y is equals to 8 into x by 2 is equals to 4x. So comparing all these things, y is equals to 4x minus x comes 3x. So this comparison equation comes n is equals to 3. Hence the correct option for this question is 3. I hope you understand this. Next question is, the displacement y of a body varies with time as y is equals to minus 2 by 3 t square plus 16t plus 2. How does the body take to come to rest? This question comes in AFMS in 2000. Let's move in the solution part. So we have few options. We know that v is equals to dy by dt. That means velocity is nothing but the rate of change of displacement with respect to time. So here the displacement is given in meter, 2 by 3 t square plus 16t plus 2. If you don't know that how to solve the differentiation part, let's say the differentiation formula that ddx or ddt of t to the power n is equals to nt to the power n minus 1. So what I am just going to do, see 2 by 3 ddt of t square. So as you can see, there will be a term, first term, minus 2 by 3t square. Okay, so minus 2 by 3 is a constant term. That's why I take out from this differentiation symbolization. So remaining part will be ddt of t square. After differentiation, 2 by 3, it will be remains constant. And after differentiation, the value comes, the place of n, it's here 2. So 2t to the power 2 minus 1, that comes 2t to the power 1. Hope it's clear. So 2 to the 4, that comes minus 4 by 3t. Same we will do with the 16t. This is the first. Second term is 16. So 16 is a constant. Again ddt of t to the power 1. It comes 1. 16 will be constant again. 1 t to the power 1 minus 1, that comes 0. And if any variable containing the 0 power, that means its value will be 1. Here we will get the value 16 only. And the differentiation of a constant term is always 0. Differentiation of a constant term is always 0. So this terms 2 will be 0. Now the final result comes minus 4 by 3 times of a t plus 16. We have to ask about the time duration. So for the body comes to rest, we must to 0. That means this value we have to equate with equals to 0. And after equating, we get the value of t, which is equals to 12 seconds. And in the option, that will be second is already 12 second is given. So the correct answer for this question is option 2. Moving ahead with the next question. A body is projected vertically up with a velocity vector v, and after some time it returns to the point from which it was projected. The average velocity and the average speed of the body for the total flight are. This question comes Aligarh Muslim University in 2000. So the options are these. Now let's move with the solution part. So average velocity is equals to total displacement divided by total time. As body returns back to initial point, total displacement is equals to 0. Hence, we can say that V average is equals to 0. Average speed is equals to distance by time, which is equals to 2h max divided by Ta plus Td. So time of ascent Ta is equals to time of descent Td. Hence Ta plus Td is equals to 2u by g. From here we can say h max is equals to u square by 2g. This term is given u is equals to v. Average speed is equals to 2u square by 2g divided by 2u by g, which comes u by 2 is equals to v by 2. As you can see, the correct option for this question is option 2. Next question is, a man is throwing ball in air. He throws next ball when previous one is at highest point. If he thrown each ball after 2 seconds, then height to which the ball rise is. The acceleration due to gravity is given here, 10 meter per second square. This question came in the BHU 2000. Here options is given 10, 20, 30 and 15 meter. Now let's move with the solution part. So as you can see, this is a man which is throwing the ball in the air. So the second ball is thrown when the first ball is at the highest point, as shown in this diagram. So we can say Ta is equals to Td is equals to 2 seconds. This is a point A. This time is the point is at highest position, and the starting position we are saying as a. So this is the starting position. And after a second time, so time interval for all the cases will be same. We know the formula from the projectile motion that h max maximum height, or we can calculate it also from the equation of motion, from the second equation of motion. So from second equation of motion, that s is equals to ut plus half at square. For the case of a height, if initial velocity will be 0, so or the object becomes in the rest, so we can say that u becomes a rest, this will becomes half. And if the body, like if we are just throwing the ball upward direction, so we are doing the work against the gravity. But when the balls start to fall down, so that work is has been done in the direction of gravity. So for that case, g must be positive and t square we are taking. So again we will reach at the same level, that h max is equals to half gt square. Hope you understand. So we just put this value, like g is given already 10 over here, the value of a t 2 second for each interval. From here we get the value of 20 meter, and in the option it's clearly given that 20 centimeter is the option 2. Next question is given, a ball is thrown up vertically with a speed u. At the same instant, another ball b is released from rest at height h. At time t, the speed of A relative to B is. This question came in the CPMT 2000. Options are U minus 2GT, third, under root U square minus 2GH, and the fourth one is U minus GT. Now we have the solution part. For a body thrown vertically upward, VA is equals to U minus GT. For body released, VB is equals to GT. So VAB is equals to VA minus VB, which is equals to U. So this question came very easy steps. Okay, and the final answer will be U. So the correct answer for this, or correct option for this question, is option 1. Next question is, an aeroplane is flying with a uniform speed of 100 km per hour along the circumference of the circle. The change in the velocity in half of the revolution will be, we have to calculate this data in the kilometer per hour. This question asked in the K set in 2000. So we have these options are given like 100, 200, 300 and 150. Let's move with the solution part. So we know about the relative velocity concept. That means delta V we have to take here in the vectorial form. So delta V is equals to V2 minus V1. V2 is equals to V1 is equals to V. So resultant velocity vector will be V1 square plus V2 square plus 2V1 V2, because the directions are opposite. So here we are taking minus 2V square cos 180 degree. And at the last we know that cos 180 will be minus 1. So this comes under root 2V square plus 2V square is equals to under root 4V square. So that final changement in the velocity comes 2 times of a V. And as you can see in this question, it is clearly mentioned that uniform speed is 100 km per hour. So the final velocity comes like 200 meter per second. And as the data in the given kilometer per hour initially, so we are taking 200 km per hour. And the correct answer or the option for this question is 200, means second option. Next question is, a man throws a ball vertically upward and it rises through 20 meter and returns to his hand. What was the initial velocity of the ball and for how much time t it remains in the air? Like the question is given a hint, a g is equals to 10 meter per second square. This question came in the MP pet in 2000. So we have given already few options like u is equals to 10 meter per second with that t is equals to 2 second. Second, u is equals to 10 meter per second with that t is equals to 4 second. And u is equals to 20 meter per second with that t is equals to 2 second. And the last option is u is equals to 20 meter per second with that t is equals to 4 second. Now the options are these. Let's move on the solution part. So as you can see this in this diagram, a man which is throwing the ball vertically upward, but because of the gravity, it will be falls down. So it covers the height 20 meter. So time for which the ball remains in the air, which is equals to the time of flight. And we know initially the ball will be in the rest position. So the maximum height we know from the projectile motion. So h is equals to u square by 2g. Velocity of the projection u is equals to under root 2 gh, where h is the maximum height from the center of the body where the displacement actually start to occur. So that comes under root 2 and the value of g is given 10. The maximum height we calculated or given is 20. So the final answer will be 20 meter per second. The time of flight we know that t is equals to 2u by g. The value of u we calculated which is a 20. So 2 into 20 divided by 10 comes 4 seconds. And time of flight also can be calculated by this formula like t is equals to 2 times of a 2 root gh root 2 gh by g. After solving, we get the value of 2 under root 2 times of h maximum by g, and from here we can easily get the value of time which is a 4 second. And from the solution or solution 1 and alternate method of solution, we reach at the same answer. Okay, so by this method we can also verify our answers or check our answer that isn't the answer is correct or wrong. So according to this, the correct option for this question is option 4. Next, the displacement of a particle in moving a straight line depends on the time t, as x is equals to alpha t cube plus beta t square plus gamma t plus delta. And student, one thing which is an extra in the form, delta is this actually, which showing the changement. And whatever you are writing here, some teachers and some students are knowing about that. This will be delta, but that is not actually delta. This is a Kronecker delta. Kronecker delta. We are using the symbol for the partial differentiation also. So the ratio of its initial acceleration to its initial velocity depends on. This question came in AFMC in 2002. So the options are only on alpha and beta, only on beta and gamma, only on alpha and gamma. So the solution of this question is x is equals to alpha t cube plus beta t square plus gamma t, and with that plus delta is given. Velocity, we know that the rate of change of displacement divided by time. So displacement is given in this form. The method of differentiation, as I told you earlier, we just use this formula ddx or t to the power n is equals to nt to the power n minus 1, and keep one thing more in your mind like d dt of a constant is always comes 0. So after differentiation, this comes 3 alpha t squared. We just like 2 minus 1 with the power of which is given. So 3 alpha t squared, 2 alpha t, here gamma only, and because Kronecker delta again is a constant working as a constant, so this will be removed. Okay. So a dv by dt comes like first time when we did the differentiation, we get the value of v 3 alpha t square plus 2 beta t plus gamma. Again, we need for the differentiation part because we know the rate of change of velocity with respect to time comes acceleration. So after one more integration or second round integration, second round differentiation, we get 6 t minus 1. So again t. Here only t is present. So 2 beta. So 6 alpha t plus 2 beta. As you can see here, the ratio of the initial. So at t is equals to 0, alpha is equals to 2 beta. Ratio of the initial acceleration and velocity depends on the factor beta and gamma. Hence, the correct answer or option for this question is option 3. Moving on the next part, a good train accelerating uniformly on a straight railway track, approaching on the electric pole, standing on the side of track. Its engine passes the pole with the velocity u, and the guard room passes the pole with velocity v. The middle wagon of the train passes the pole with the velocity. Here the options are given. Now let's move with the solution part. So V naught is equals to velocity of the middle wagon. V naught square minus U square is equals to 2ax. And V square minus V naught square is equals to 2ax. What we did, we just do the differentiation part and get the result V naught square plus U square plus V square by 2. And the resultant final velocity comes under root U square plus V square by 2. And this is the correct answer for this question is in the option 3. Next, the graph of an object motion along the x-axis is shown. In the figure, in instantaneous velocity, the instantaneous velocity of the object at any point A and B are VA and VB respectively. Then first option is given, VA is equals to VB is equals to 2 meter per second. Second, VA is equals to 0.5 meters per second. Is less than VB. And third, VA is constant. VB is less than to that. And fourth option is VA is equals to VB is equals to 0.5. Now move with the solution part. So instantaneous velocity concept arises from differentiation part. So differentiation comes with the slope. So dx by dt related with a slope. So that slope comes VA is equals to VB, which comes 4 by 8, which is equals to 10 by 20. And approximately what we are doing? We are doing 0.5 meter per second. Hence the correct answer for this question is option. Next question we have, a car of mass 1000 kg is moving off a speed of 30 meter per second. Brakes are applied to bring the car to the rest. If the net retardation of the force is 5000 Newton, the car comes to stop after traveling d meter in t second. Then we have an option that value of d is 150, time t is equals to 5, d is equals to 120, t is equals to 8, d is equals to 180, t is equals to 6, or d is equals to 90 and t is equals to 6. So let's move with the solution part, students. We know the basic formula of force, that is the force is equals to mass into acceleration, which is F is equals to ma. From here we can calculate the value of acceleration, which comes 5 meter per second square. After putting the value of force, which is a 5000, and mass, which is a 1000, applying the third equation of motion. Which is v square minus u square is equals to 2a. Instead of s, we are using here d. So initial velocity is given 30 meter per second and it remains as in rest after moving. So the final velocity comes 0. So 0 minus 30 square is equals to minus 2 into 5 times of a d. After a solution, we get the value of a d is 90. So among all these options, we get only single option where the d is equals to 90 is given. But for the more solution, more accurately, we get the value of a t also. So v minus u is equals to 80. We have what I did, I just applied the formula equation of first motion. So first equation of motion, which we know simply that is the v minus u is equals to 80 or v is equals to u plus 80. So I'll just put this value like final velocity is given here 0, initially 30 and the value which we calculated here 5. I'll just put it here and calculate the value of a t which is becomes 6. So finally we like prove this value the d is equals to comes 90 and t is equals to come 6 seconds. Hope you understand, students. Moving ahead with the next question. The distance traveled by a body moving along a straight line in time t is proportional to tq. The acceleration time, that is at graph for the motion of the body will be. Here we have a given different kind of plots. So now let's move with the solution part. We know here in the question it is a given x is directly proportional to tq. This given in the question. So dx by dt comes the value of gives the value actually v. So v is equals to dx by dt. After differentiation we get 3t square. And once again after doing the differentiation part we get the value of acceleration which is 90. This will be not 3t square, student. There will be some mistake. This will becomes 90. Sorry, this will become 60. Wait. Yes, after differentiation, this will become 60. So might be there will be a printing mistakes. This will become 60. Yes. And we know like A is directly proportional to T from here. So the curve will be a straight line. Hence the correct option for this question is the first. Moving on the next part, which is the question number 37. A ball is dropped vertically downward from a height d above the ground. It hits the ground inelastically and bounces vertically, neglecting subsequent motion and air resistance. Which of the following graph represent the variation between the speed and height h correctly? Now let's move with the solution part. So we have velocity and height relation, that is v square is equals to u square plus 2g. H here g is negative because the body is moving upwards. So that body is doing the work against the gravity. So v square is directly proportional to h. The graph was like v versus h is a parabolic. For a downward motion, u is equals to 0, v square increases. And for upward motion, v square decreases with h. So we have the correct option is a 4. So this is all about for today's class. I hope you understand the topic. Keep watching this video. Take care and thank you for watching this video.